Machine embroidery is an embroidery process whereby a sewing machine or embroidery machine is used to create patterns on textiles. It is used commercially in product branding, corporate advertising, and uniform adornment. Hobbyists also machine embroider for personal sewing and craft projects. There are multiple types of machine embroidery. These include free motion sewing machine embroidery. This uses a basic zigzag sewing machine. Much commercial embroidery is still done with link stitch embroidery. The patterns may be manually or automatically controlled. More modern computerized machine embroidery uses an embroidery machine, a sewing embroidery machine that is controlled with a computer that will embroider stored patterns. These may have multiple heads and threads. Free motion machine embroidery. In free motion machine embroidery, embroidered designs are created by using a basic zigzag sewing machine. As it is used primarily for tailoring, this type of machine lacks the automated features of a specialized machine. To create free motion machine embroidery, the embroiderer runs the machine and skillfully moves tightly hooped fabric under the needle to create a design. The operator lowers or covers the feed dogs or machine teeth and moves the fabric manually. The operator develops the embroidery manually, using the machine's settings for running stitch and fancier built-in stitches. In this way, the stitches form an image onto a piece of fabric. An embroiderer can produce a filled-in effect by sewing many parallel rows of straight stitching. A machine's zigzag stitch can create thicker lines within a design or be used to create a border. Many quilters and fabric artists use a process called thread drawing to create embellishments on the projects or to create textile art. Free motion machine embroidery can be time-consuming. Since a standard sewing machine has only one needle, the operator must stop and rethread the machine manually for each subsequent color in a multi-color design. He or she must also manually trim and clean up loose connecting threads after the design is completed. As this is a manual process rather than a digital reproduction, any pattern created using free motion machine embroidery is unique and cannot be exactly reproduced, unlike with computerized embroidery. With the advent of computerized machine embroidery, the main use of manual machine embroidery is in fiber art and quilting projects. Though some manufacturers still use manual embroidery to embellish garments, many prefer computerized embroidery's ease and reduced costs. Computerized machine embroidery. Most modern embroidery machines are computer-controlled and specifically engineered for embroidery. Industrial and commercial embroidery machines and combination sewing embroidery machines have a hooping or framing system that holds the framed area of fabric taut under the sewing needle and moves it automatically to create a design from a pre-programmed digital embroidery pattern. Depending on its capabilities, the machine will require varying degrees of user input to read and sew embroidery designs. Sewing embroidery machines generally have only one needle and require the user to change thread colors during the embroidery process. Multi-needle industrial machines are generally threaded prior to running the design and do not require rethreading. These machines require the user to input the correct color change sequence before beginning to embroider. Some can trim and change colors automatically. A multi-needle machine may consist of multiple sewing heads, each of which can sew the same design onto a separate garment concurrently. Such a machine might have 20 or more heads, each consisting of 15 or more needles. A head is usually capable of producing many special fabric effects, including satin stitch embroidery, chain stitch embroidery, sequins, applique, and cutwork. History. Before computers were affordable, most embroidery was completed by punching designs on paper tape that then ran through an embroidery machine. One error could ruin an entire design, forcing the creator to start over. In 1980, Wilcom introduced the first computer graphics embroidery design system to run on a mini-computer. Melco, an international distribution network formed by Randall Melton and Bill Childs, created the first embroidery sample head for use with large shear-fly looms. These looms span several feet across and produced lace patches and large embroidery patterns. The sample head allowed embroiderers to avoid manually sewing the design sample and save production time. Subsequently, it became the first computerized embroidery machine marketed to home sewers. The economic conditions of the Reagan years, coupled with tax incentives for home businesses, helped propel Melco to the top of the market. At the Show of the Americas in 1980, Melco unveiled the Digitrack, a digitizing system for embroidery machines. The digitized design was composed at 6 times the size of the embroidered final product. The Digitrack consisted of a small computer, similar in size to a BlackBerry, mounted on an X and Y axis on a large whiteboard. It sold for $30,000. The original single-needle sample head sold for $10,000 and included a 1-inch paper tape reader and 2 fonts. The digitizer marked common points in the design to create elaborate fill and satin stitch combinations. Melco patented the ability to sew circles with a satin stitch, as well as arched lettering generated from a keyboard. An operator digitized the design using similar techniques to punching, transferring the results to a 1-inch paper tape, later to a floppy disk. This design would then be run on the embroidery machine, which stitched out the pattern. Wilcom enhanced this technology in 1982 with the introduction of the first multi-user system, which allowed more than one person to work on the embroidery process, streamlining production times. Other industries entered the embroidery industry after several computerized embroidery companies contracted it to provide sewing heads. Later, the Japanese company Tajima provided sewing heads that were capable of using multiple threads. Singer failed to remain competitive during this time. Melco was acquired by Sora in 1989. The major embroidery machine companies eventually adapted the commercial systems and marketed them to companies such as Genome for home use. Since the late 1990s, computerized machine embroidery has grown in popularity as costs have fallen for computers, software, and embroidery machines. Many machine manufacturers sell their own lines of embroidery patterns. In addition, many individuals and independent companies also sell embroidery designs, and there are free designs available on the internet. The computerized machine embroidery process. Machine embroidery is not as push-button as many people tend to believe, and can be a very tedious process depending on numerous variables. The basic steps for creating embroidery with a computerized embroidery machine are as follows. Purchase or create a digitized embroidery design file that works with the brand of machine. Edit the design and/or combine with other designs with costly software. Load the final design file into the embroidery machine after making sure it is the right format and it will fit in the hoop you need. Stabilize the fabric and place it in the machine. Start and monitor the embroidery machine to change thread colors, rethread machine, troubleshoot problems, etc. And have plenty of needles, bobbins, a canevas, a small brush, and scissors on hand. Toss out botched project due to wrong stabilizer for item, machine malfunction, wrong thread, badly digitized design, etc. Repeat process from the beginning till it's right. Design files. Digitized embroidery design files can be either purchased or created with industry-specific embroidery digitizing software. Embroidery file formats broadly fall into 2 categories. The first, source formats, were specific to the software used to create the design. For these formats, the digitizer keeps the original file for the purposes of editing. The second, machine formats, were specific to a particular brand of embroidery machine. Here, the files are available for use with particular embroidery machines and are not easily edited or scaled. Wilcom developed the EMB file format, which is the designer's file format of choice, ensuring optimum stitch quality. This format stores the true object-based properties and means that they can easily resize, recolor, adjust for fabric types, etc. with a simple click for each project. Once ready, the EMB is exported into any machine format required for that specific stitch out. Embroidery machines generally have one or more machine formats specific to the brand. However, some formats such as Tajima's, DST, Melco's, EXP, CND and Barudan's, FDR have become so prevalent that they have effectively become industry standards and are often supported by machines built by rival companies. Machine formats generally contain primarily stitched data and machine functions and thus not easily scaled or edited without extensive manual work. Many embroidery designs can be downloaded in popular machine formats from embroidery websites. However, since not all designs are available for every machine's specific format, some machine embroiderers use conversion programs to convert from one machine's format file to another, with various degrees of reliability. A person who creates a design is known as an embroidery digitizer or puncher. A digitizer uses software to create an object-based embroidery design, which can be easily reshaped and edited. These files retain important information such as object outlines, thread colors, and original artwork used to punch the designs. When the file is converted to a stitch file, it loses much of this information, rendering editing difficult or impossible. Software vendors often advertise auto-punching or auto-digitizing capabilities. However, if high-quality embroidery is essential, then industry experts highly recommend either purchasing solid designs from reputable digitizers or obtaining training on solid digitization techniques. Editing designs. Once a design has been digitized, an embroiderer can use software to edit it to combine it with other designs. Most embroidery programs allow the user to rotate, scale, move, stretch, distort, split, crop, or duplicate the design in an endless pattern. Most software allows the user to add text quickly and easily. Often the colors of the design can be changed, made monochrome, or resorted. More sophisticated packages allow the user to edit, add, or remove individual stitches. Some embroidery machines have rudimentary built-in design editing features. Loading the design. After editing the final design, the file is loaded into the embroidery machine. Different machines require different formats that are proprietary to that company. Common design file formats for the home and hobby market include Art, Hus, Jeff, Pez, SOT, and VIP. Embroidery patterns can be transferred to the computerized embroidery machines through cables, CDs, floppy disks, USB interfaces, or special cards that resemble flash or compact cards. Stabilizing the fabric to prevent wrinkles and other problems. The fabric must be stabilized. The method of stabilizing depends on the type of machine, the fabric type, and the design density. For example, knits in large designs typically require firm stabilization. There are many methods for stabilizing fabric, but most often one or more additional pieces of material called stabilizers or interfacing are added beneath or on top of the fabric, or both. Stabilizer types include cutaway, tearaway, solvay, water-soluble, heat-engone, filmoplast, and open mesh, sometimes in various combinations. For embroidered wearable items, the fabric is placed in a hoop. This is then attached to the machine. An X and Y drive mechanism moves the hoop under the needle following the design coordinates created when the design was digitized for embroidery. Learn more on choosing the right stabilizer for your embroidery job here. Embroidering the design. Finally, the embroidery machine is started and monitored. For commercial machines, this process is more automated than for the home machines. Many designs require more than one color and may involve additional processing for appliques, foam, or other special effects. Since home machines have only one needle, every color change requires the user to cut the thread and change the color manually. In addition, most designs have one or more jumps that need to be cut. Depending on the quality and size of the design, sewing a design file can require anywhere from a few minutes to over half a day. Embroidery machines. Not all machines are solely used for embroidery, some are also used for sewing. Some of the more advanced features becoming available include a large color touchscreen, a USB interface, auto-threading, built-in design editing software, embroidery advisor software, and design file storage systems. Commercial embroidery machines can be purchased with a set number of needle colors per head. Industrial embroidery machines are available with 1 to 56 heads. Commercial and contract embroidery factories. Factories can have a few small machines or many large machines, or any combination of machines. Contract embroidery is done on goods that the customer supplies to the embroidery house and is limited to the trade. ASR and marketing firms use these services almost exclusively. A company offering contract embroidery sews designs onto wearable items for brokers, other embroiderers, specialty firms, and screen printers at wholesale rates. The customer of a contract embroiderer usually supplies the items to the factory and only pays for the embroidery service. Commercial embroiderers and some contract embroiderers offer the services to the public and can supply the wearable items, and usually have a vast collection of stock designs and text available, keeping up with current market trends, and offering names and personalization as well as designs for embroidery. Other supplies. Almost any type of fabric can be embroidered, given the proper stabilizer. Base materials include paper, fabric, and lightweight balsa wood. Machine embroidery commonly uses polyester, rayon, or metallic embroidery thread, though other thread types are available. 40WT thread is the most commonly used embroidery thread weight. Bobbin thread is usually either 60WT or 90WT. The quality of thread used can greatly affect the number of thread breaks and other embroidery problems. Polyester thread is generally more color-safe and durable. High-quality embroidery thread is produced by Exquisite Gunald, Madeira, and Robison Anton. Other associated costs are thread, stabilizer, purchase designs, needles, bobbins, and other miscellaneous tools and supplies. Embroidery glossary. A more thorough list of applicable terminologies is available at http://abcon.com. Glossary. PHP. Applique, French term meaning applying, usually by sewing one piece of fabric to the surface of another. A cut piece of material stitched to another adds dimension and texture and reduces the stitch count. Backer, stabilizer. Backing and stabilizer are often used interchangeably to refer to materials, generally non-woven textiles, which are placed inside or under the item to be embroidered. The backing provides support and stability to the garment, which will improve the quality of the finished embroidered product. Backings come primarily in two types: cutaway and tearaway. With cutaway, the excess backing is cut with a pair of scissors. With tearaway, the excess is torn away after the item is embroidered. Additional types of stabilizer can be dissolved by water or heat. Bobbin, a small spool of thread inside the rotary hook housing of a sewing machine. The bobbin thread forms the stitches on the underside of the garment. Bobbin thread holds the top embroidery thread to the garment. The bobbin on an embroidery machine works in the same manner and for the same purpose as on a standard sewing machine. Digitize the computerized technique of turning a design image into an embroidery program. Special software is used to create plotting commands for the embroidery machine. The commands are transferred to the machine's logic head by a designated embroidery language. Fill stitch. Fill stitches are a series of running stitches sewn closely together to form broad areas of embroidery with varying patterns and stitch directions. Hoop clamping device used to hold the backing and fabric in place in the machine. Running stitch. One straight line of stitches, often used for fine details, outlining, and underlay. Satin stitch, also known as zigzag stitch. A satin stitch is a line, border or edge produced by thread being alternately stitched to either side of a baseline. Satin stitches are generally limited to a maximum of 1/2 in stitch length before some alternate technique must be used, such as split stitching or fill stitching. Underlay, a stabilizing pattern of embroidery which, if used, precedes the main body of satin or fill stitching. It consists of one or a combination of running stitches for centering, edging, paralleling, or zigzagging the design area. A money and time-saving technique is to use, instead of a large amount of embroidery thread for underlay, a fancy specialty stitch saver patch material that simulates underlay.